Alright, so I just want to show you what it sounds like before you do any changes to the filtering. It's a little bit tricky because I'm reaching behind, you can't see where the controls are, but I'll tell you what I'm doing as I do it. And we're just going through the test cabinet down under the bench there, which is a G12T75 Celestion in an open back cab, and that's mic'd up with an SM57 on axis. So going into the Brilliant, or now top boost channel, we've got both the bass and the treble set about midway, and I'll gradually go up in the volume, and then we'll play with the top boost controls. Cut is all the way down, so as close as being out of circuit as it can be. Alright, so that was full volume with the treble and the bass set about midway. We'll try that again with the treble. Bugger it, let's go all the way up. Leave the bass about midway, just to show you the top end that the thing has now. Alright, so now I'll show you the ghosting as we play further up the neck, single note stuff. So I do agree that's a little bit distracting. In a mix it'd probably disappear a bit, but when you're sitting there listening to the guitar in isolation, it is quite distracting. So I can understand the customer's point of view when he wants to increase that filtering. Alright, so while we're here and we've got it powered up, we'll just check the normal channel. I've fixed those jack connections. So it can make some chordal stuff a little bit messier as well, but it's sort of, it's the vibe of the thing. It's just a bit looser, a little bit more out of control, a bit more edgy. It's a little bit more interesting, to be honest. Instead of just a straight up sort of hard clipping pedal sort of type tone, it's a bit more complex. It's got some more intricacies to it, but you know, maybe it's not to everyone's taste. Now just going into the Trem Vibe channel. I showed you before, I'll show you proper a little later, but we'll just do a quick demo. Here's one you'll all know. Yeah, boy. Alright, so we'll change our filtering now, and I'll give you a demo of what it sounds like after that's done. Alrighty, so I've carefully removed the cap on the left, and we're going to install the one on the right. So that's going from 16 and 16, that's the B plus and the screen grid nodes, to 32 plus 32. Now originally we had nominally 26, but take note of the tolerances there, minus 10 plus 30, which is actually really tight for a electrolytic capacitor. With those 10 microfarads piggybacked onto the back of the 16, we had about 26 per node, so we've got 32. So it's not a huge change, but it makes for a much neater installation, less components to fail, and less wires to have to squeeze onto those little terminals. And in the style of Bob Ross, there's our happy little filter cap. Down there, that's our 32 and 32, carefully rewired because we can't spare any more length on those wires. So I had to remove them and resolder them very carefully, being mindful not to melt the jacket. Alright, so let's see where the ripple sits with that new cap in place. Starting to get voltage on the rectifier output. Up she goes, starting to conduct on the output stage. Should settle at 6 point something volts per side. Alright, so yesterday I believe I miscalculated the bias a little bit. I was estimating around 15 watts. I believe I had the multimeter hooked up to ground. I wasn't taking into reference the cathode voltage. I was measuring the plate voltage in reference to ground. So now we've actually got the negative of this meter connected to the cathodes of the output valve, so it's showing the actual drop across the valves. And we're sitting at around 14 watts, which is bang on what we want. And the ripple has about halved in its quiescent state. So it was sitting around 20 volts before, now it's sitting around 10. Probably still be a little bit of ghosting, sitting at 10 volts there, but it'll be a lot less than it was before. So let's try that out. Alright, so it's still there. I'd say it's sort of perceptibly half what it was, but it's still quite noticeable. But in isolation, it's quite noticeable. In a mix, in the scope of playing with a band, no one's going to pick that up. Our ears do this thing called masking. So if something is, I think it's 3 or 6 dB below another signal, our brain doesn't care about the quieter one because it's trying to mask out threats from back when we were, you know, cave people and worried about a bloody woolly mammoth skewering us. So primarily evolution has made us care more about the things that are loud because they're more likely to be an immediate threat to us. Which in some cases on high power amplifiers is an immediate threat because it'll send you deaf. So what I'm trying to say is, in the scope of a band, in the scope of a recording, you're not going to hear the ghosting. You just hear it in isolation. We can sit here with our ear 6 inches from the speaker all day, playing weird notes and chords, but at the end of the day, it's going to be a very useful amp. It sounds fantastic, and it will sit in a mix beautifully. So I'm happy with this, 100%. I'm going to put it back in the cabinet, put the knobs and stuff back on, and we'll test it with the stock Celestion speakers that are in the cab. Alright, so just testing it for output before we take it off the rig. Giving it 1 kilohertz. 1 kilohertz. It's about 22 about 22 volts RMS into 16 ohms at the onset of clipping, which is pretty well bang on 30 watts RMS into 16 ohms. So yeah, happy and healthy. Because there's almost always just one last thing to take the wind out of my sails, we've just got to change that pilot light globe because she just gave up the ghost. Well, it turns out we just need to clean the contacts a little bit, and there she glows. And of course, champions, I've almost forgot what I mentioned in the first video, and that's that these screw inserts over here are, now normally they've got a hex thread so you can remove them rather easily, but I think we're going to have to come up with a creative solution here. So the show ain't over yet. It never is. Well, that's some dumb shit. I've used like a nutsert, what's meant for sheet metal in the wood. So of course it just spins because there's no anything to key it into, and because it's stripped, it didn't even need to spin, and that one's glued in with epoxy, so it's going to be fun to remove. It just never ends, man. You just can't win on these jobs. It's just constant grind, and just won't be happy till I spend 4 days on it. So instead of this bullshit, what we have out here is these things called demon nuts. I use these on my cabinets. Just basically threaded inserts with a coarse external thread and a hex drive. We'll use one of them, and fortunately they happen to match the thread on the stock brass screws, so we can reuse them. No harm done. Alright, so I've got all of them out with varying degrees of difficulty, but now we've got to drill out the existing holes to 8mm because the new demon nuts have a slightly larger diameter. We'll just use a vacuum to clean up the mess. And we'll just use our impact driver with a 5mm Allen key. Alright, and there's the final result. It's actually where the little plywood cleats have delaminated a little bit from the previous inserts. These actually work to pull them all back together again because they're sort of like screws. And they've got a flange on the front. So that's sort of pulled the ply back together, so that's good. But yeah, it's the kind of shit that your average tech doesn't have, but I'm an ex-cabinet maker, so I know about these things. Let's check everything's aligned. Don't want to have to fight anything to get it all positioned. Now, I've just noticed that the chassis wants to move this way a little bit in the cabinet, so we'll do that now. Now, one thing to notice is there's 2 lengths of screws for the rear panel. Do not put the long one in these top 2 holes, or you get a pretty rude shock. Alright, champions, there she is back in one piece. We've closed up the gap at the top there. We've flipped over the base, which is sort of like the draw runner thing that this rides on, that's got a rebate. It looks like for a long time, possibly since it was first manufactured, that used to be around the other way. So now we've closed up that gap a little bit, so less chances of shmoo or dust or whatever leaking down in there. Everything's nice and tight now. We've not got any issues with these screws being stripped. That will be a lifetime thing now that you've actually got the threaded inserts. These ones seem to be okay because you're not removing them to service it, so they've probably been removed very much fewer times or not at all. So everything's wired up, everything's plugged in, ready to go. So let's mic this thing up and give it a final test with those speakers, and then try and get out of here and have at least a third of a day off this week.
Oh my god, legends, this one's finally done. Like a lot of restorations, it fought us at every turn. Nothing new there. I sometimes feel like the restoration jobs aren't complete until you truly hate that amplifier and hope you never see it again. So this is sort of that, but I think the results speak for themselves. This thing sounds fantastic. But anyway, I hope he's happy with this one, and if it needs any tweaks, of course, I'm always open to sorting that out for my customers. But I reckon we're a lot closer now than it would have been when it came into his ultimate amplifier. And he said this is going to be his lifer, so, you know, I really want him to be happy with it forever and ever. So, see you on the next one. I'll have the parts in for the Super Bass. Probably it is Australia, so I don't know, like 2026 or something. So I guess I'll talk to you then. But in the meantime, we'll get back to regular broadcasting. So until then, take it easy and, you know, be good to your mother and drink lots of water.